So my name is Keely Makmer-Wessels. I am coming to you from Pororoa at the moment. I would call myself a math coach. I've supported teachers mostly in the United States for about the last decade around instructional practices. I've worked for Oakland Unified for a long time. I've also worked for a couple other organizations that are specifically thinking about math and English language learners. So that's something that's of particular interest to me of how we're supporting students to learn math and English at the same time, which is why I'm going to be talking about some math language routines today. During this session, please forgive me, I do say math instead of maths. If there's anything else that needs translation, I'm sure we can co-construct some meanings about what I'm saying in my American terms and some Kiwi terms. Of course, throw any questions into chat as we go. I will definitely be checking that out. And also feel free to unmute and ask questions. So in this session today, my goal is really to make sense of the purpose and the power of math language routines in ways that they provide access to mathematics and language, and that they really give opportunities to really amplify student thinking in classrooms. So I will talk a little bit about instructional routines and then think about why these math language routines are important. And then we'll have a chance to experience two of these language routines as learners. And then we'll kind of synthesize with our teacher hats on about what these means. So jumping into instructional routines. So first of all, like, what is an instructional routine? So when I say instructional routine, I'm thinking about not like a management routine of, how your students enter class or how you pass out papers, those sorts of things that are important to have a routine for in a classroom space. But an instructional routine would be something like a which one doesn't belong, or a think, pair, share, notice and wonder, number talk. Those are all instructional routines that's that structured series of student and teacher moves that are really supporting the mathematical learning and sense making in a classroom. So that's what I'm saying when I'm talking about instructional routines. And why these are important, right? They really give that predictable structure for both the teacher and the students, right? It makes it easier for students to focus on what they're learning since they know the expectations for how they're learning, right? Provides a safer learning environment. It also allows teachers to focus on really listening to student thinking since they're using a familiar structure of how they are facilitating the class. So these are really pushing on who's doing the math in math class, right? Promoting student discussion and engagement. That's why instructional routines are important. So I'm curious if I've said a little bit on instructional routines, named a few examples of which one doesn't belong, think, pair, share, notice, and wonder. I'm curious if one of these instructional routines is something that you use regularly or something that you've seen someone else do, or like, what are your favorite go-to instructional routines? Thank you, Nick. Mini whiteboards. You've got a routine with mini whiteboards. Nick, would you be willing to unmute and say a little bit more about what's your routine with using mini whiteboards in your class?
Hi, I've only just started using them, but the kids, and this is with senior high school. Basically, I'll have the questions on the PowerPoint. Often it's just true false, to be honest, but sometimes it's other things as well. And it just means I can keep, they write their answer and then I go tahi rua toru and then they lift them up and I can just glance around the room and see who's got the right answer or not. But I often get penises, but that's because I teach a mixed classes. Okay, that's it.
Awesome, thank you. So I like that, rather than asking the question, you've established this instructional routine in your class where instead of asking a question, one student answers, you're asking a question and all students are answering. So really pushing on who's engaging and doing the math in math class. And it's not just going to be one person at a time. Awesome. I also appreciate you said something about teaching older students, since I think sometimes we talk about mini whiteboards and everyone's picturing like, 5-year-olds on a carpet with them, but no, like those are useful in, secondary school as well, for sure.
The kids absolutely love them. When I say we're going to do mini whiteboards, they're excited. So sort of, yeah, they're just big kids, really.
Exactly. Big kids still have mini whiteboards. Great. Any other instructional routines that people want to throw out in chat of that they use in class or they've seen work well in a class they've observed? Okay, so having the do now activity, establishing that that's going to happen at the beginning of class. Awesome. And appreciate the suggestions about giving them a doodle minute to get any of those non-math related doodles out. Okay, so I'm gonna move into thinking a little bit more about a specific type of instructional routine called a math language routine. So I'm curious with like a fist to 5 of how familiar are you with math language routines? So 0 would be, you've never heard of a math language routine before, and a 5 being you use these all the time when you're teaching. So if you could throw a number into Zoom chat, that would help me out of like, ever heard of them? Okay. This is some consistent data. Okay, cool. Awesome. Well, I'm super excited I get to introduce these to you as an instructional routine. So I'm going to first talk a little bit why I think these are important to think about in math class and why I think language and math is so important. And then we'll get into more about what these math language routines are. So there's this relationship between math and language. And I think we had this kind of old paradigm of thinking about the relationship between mathematical content and language is like, hey, there's some vocabulary. The overlap is students need to know what a parallelogram is, right? And I think some of the thinking has shifted to think about this overlap being a lot greater of all the different ways that students really make meaning through using language, right? Through listening and speaking and writing and reading. And students really express their sense making through language, and we're asking students to use language in purposeful ways during math class. So there's just kind of a greater overlap between learning math and learning language, right? We're not handing students a bunch of fact sheets and having them do problems with only numbers in them and not talking to anyone, right? So there's all these ways that language overlaps with the content in math classrooms. And so it's important to attend to what is it we're asking students to do with language, right? So we talk about the language functions of what students are actually doing with language as they engage with content and interact with others in a math classroom, right? That we're asking students to use language for a specific purpose in class, and they have to express ideas and communicate with others and make sense and show understanding, right? Some of the different ways that they might, some of the different functions in math class might be you're asking students to explain their thinking, or you're asking them to classify shapes, or you're asking them to evaluate if someone else is, solution method is valid or not, right? There's all these different language functions that we ask students to do when they're thinking about and learning math. So with all of that in mind about this overlap of language and mathematics and the purpose of math, or the purpose of language within a math class, right? There's these 8 math language routines. These came out of a project called Understanding Language out of Stanford University a few years ago, that they developed these language routines that are a particular subset, that I'd call them a subset of instructional routines, that they have this particular purpose for really amplifying, assessing, and developing students' language alongside their mathematics. So they're intended to be structured, but also adaptable. They really emphasize the use of language that is meaningful and purposeful. And these routines can be adapted to fit different mathematical content and contexts in both primary and secondary classes. So these are the 8 routines. We're going to talk more specifically about 2 of them, which are Stronger and Clear Each Time and 3 Reads. So I'm going to ask you to start by playing the role of students and experience both these routines as a year 7 student might. So we will come back and debrief with our teacher lenses later. So if you got a teacher question, I encourage you to write it down, hold on to it so you don't forget it. But I'm going to ask for the next about 20 minutes to experience these 2 routines as a year 7 student might. Okay, so let's put on our student hats and start with math language routine 6, which is a 3 reads. So I'm going to read, we're going to read the same situation 3 times. This first time, I'm going to ask you to really not worry about the numbers or anything else and just think about what's the context of this situation, right? What's happening here? Go ahead and listen up, and I'm going to read this one out loud. So, Lynn and Noah each have their own recipe for making sparkling orange juice. Lynn mixes 3 liters of orange juice with 4 liters of soda water. Noah mixes 4 liters of orange juice with 5 liters of soda water. So I'm hoping someone is willing to share what is the context of this situation. If you're willing to share, you can just go ahead and unmute or give me a thumbs up in the reaction. I think is it Justina? Would you be willing to unmute and share a little bit more out loud about what the context is here?
Sure. It's Justina. And yeah, there's just two kids. Don't actually remember their names, but they're mixing some juice together.
Awesome.
Drinks in different ratios. Yeah.
It's Justina?
Justina. Justina, with like the J is like ignored.
Justina. Okay, got it. Justina.
Yeah.
Thank you. Thank you so much. Okay, so they're mixing drinks. And I see some other people adding into chat as well. Does anyone add anything else out loud about what's happening in this context, this situation? Okay, I think we got it. Got some questions coming up. What are they going to do with it? Okay, making different drinks. So we are going to move on to our second read. And this time I'm going to ask you to focus on what are the quantities in the problem. What here can be counted or measured? This could be something that is implicitly stated or, is explicitly stated or is implicit in the problem, okay? And I will put it up in, and I'm going to put it up on my screen, and I'm wondering if someone would be willing to read out loud. I have a volunteer to be willing to read out loud for us.
I will.
Thank you so much, Nick. So here we go. You're up, Nick. Lisa, I'll have you do the next one. I see you in chat.
Okay.
Ahead,
Lynn and Noah each had their own recipe for making sparkling orange juice. Lynn mixes 3 liters of orange juice with 4 liters of soda water. Noah mixes 4 liters of orange juice with 5 liters of soda water.
Awesome. Thank you so much, Nick. Okay. So you can add into chat or feel free to unmute, whatever you prefer. But what are the quantities in this problem? Okay, so we've got amount of orange juice, an amount of water. What else we got? Okay. I'm seeing Lynn has 7 liters. Okay. So I'm seeing Lynn has 7 liters and Noah has 9 liters. Would someone be able to come off? I'm not seeing the 7 or the 9. I'm not seeing those in the problem. Could someone come off and explain where that 7 and 9 are coming from for us?
I can add to that. The 7 is how many parts in total Lynn has got, and the 9 is how many parts in total Noah has got.
Got it. Thank you. Okay, so combining those for how much of their sparkling orange juice they'll have. Awesome. Anything else we're missing here in terms of quantities? Yeah, the total amount of OJ and water, exactly. Oh, the ratios. Catherine, could you say more about where you're seeing ratios in this problem? Oops, oh, I didn't mean to do all that. There we go. Catherine, can you say more about those ratios?
The ratios come from the comparison of the amount of orange juice to the amount of soda water per person.
Okay.
Okay, so ratio of orange juice to soda water. Awesome. Great. So we got 3 to 4 and 4 to 5. So thank you. Okay. So we've now thought about the quantities and we thought about the context here. So we'll move on to the last part of our 3 read. If I was in a classroom, I'd want to have all these quantities listed somewhere where you could still see them, but instead on Zoom, I'm going to end up clearing all my drawings. So for the 3rd read, I think I had Lisa who volunteered. So on this read, I'd like everyone to start brainstorming what are some possible ways you might get started on this. And Lisa, you can go ahead and read when you are ready.
Okay. Lynn and Noah each have their own recipe for making sparkling orange juice. Lynn mixes 3 liters of orange juice with 4 liters of soda water. Noah mixes 4 liters of orange juice with 5 liters of soda water. How do the two mixtures compare in taste?
Awesome. So take 10 seconds of quiet think time about how you might get started to answer this question, or what representation might help you. Okay, and if anyone would like to share in chat, or you can come off of mute and share, what are some ideas, not looking for an answer yet, of just like, how might you get started? What's a representation that could help?
Which has more orange than water? Which has a larger proportion of orange juice?
Okay.
Because that would make it stronger.
Okay, so thinking about which one has a bigger proportion of orange juice. Okay, I'm seeing, drawing a jug and using colors. So I see a couple of people saying drawing a picture, maybe perhaps using percentages, make a table to make sense of it. Nick, could you tell me about, you could do spots? I don't know what that one means. Tell me more about that.
So you could just sort of make a circle for each one, and then you have orange spots and for orange juice, and clear spots or white spots for the soda water, and that way you can sort of look at it and get an idea of what it's going to look like.
Awesome. Okay. Thank you. So we've got some different ideas of how we might draw this, how we might use a table, use percentages, use proportions, use fractions, lots of different ideas from this group about how to get started. So that concludes the 3 reads, which is our first math language routine. We are now going to move into a second math language routine, and we're going to work on solving this problem. So don't give away too much more information in the chat just yet. We're going to try out this math language routine called Stronger and Clearer Each Time. And this routine is going to involve some individual think time, followed by some structured pair meetings where you'll have the opportunity to both speak and listen about this problem. So before I go into more details about the structured pair meetings, we are going to take 3 minutes of individual thinking and writing time. So in this first draft, you're going to have a chance to work on how you might solve this problem. I'm going to put into chat a graphic organizer. So you can choose to either work on this problem on that graphic organizer or work on your own paper, whatever you prefer. We're just going to take about 3 minutes to work on how we might solve this, right? We had some ideas that were shared. I'm putting the problem back up there, but what I just put into chat will kind of tell you to make a copy. And then if you go down to page 2 on this document, page 2 is the template. It's got the prompt at the top. You can type in here kind of like, what's your initial thinking about how you would solve it? So we'll work on that, and I'll tell you more about the structured pair meetings. So we're going to take 3 minutes of work time. You can either work in this graphic organizer if it's easier for you, since we're on Zoom and you want to be able to write. You can work on some paper in front of you, whatever you prefer. But right now we're doing our first draft thinking. So we'll take 3 minutes, and Pip, now would be a great time if you could make me host. Thank you.
Done.
Okay, hopefully that was enough time to get a draft down, some initial thinking about how you might compare, how do these two mixtures compare in taste. So that was the first draft part of this routine. And now we are going to move into some structured pair meetings. So if we're all together, I'd have everyone stand up and find a partner somewhere and take your paper so you could really show them. In this case, you're going to explain some out loud. You might need to show a diagram up to your screen, up to your camera, whatever you need to do. But we're going to go into these structured pair meetings. So it's going to be 3 minutes. Each partner will get 1.5 minutes to share their response. If there's still time in that 1.5 minutes, the partner who's listening can kind of push their thinking a little bit using some of these sentence stems, right, to kind of follow up. So I'm going to add those sentence stems into chat so you have those. And we're going to move into breakout rooms in just a moment. So it'll be, again, 3 minutes in the breakout rooms, 1.5 minutes each person. If something doesn't work out in your breakout room, if there's no other person there, or when you go, or any other issue, just please come on back to the main room. Any questions before we go into our first pair meeting of 3 minutes? Okay. Let's go ahead and get started. I'll see you all back in 3 minutes.